Okay, I'm not going to go through number 23. Notice number 23 has a red circle, so that what you see here, the proof is in the back of the book. But do notice how to differentiate between the two overlapping triangles. And the basic idea here is we want to prove that VYX, okay, this angle here, and WYZ, this angle here, are congruent. So if I can prove that these two triangles, these two larger triangles, are congruent, triangle TYZ and UYX, then I know that this angle here for this triangle is congruent to this angle here for this triangle. So if I just subtract TYU out of that, then I've got angle VYX and WYX, and they must be congruent. That's the main idea there. Okay, looking at number 24, I want to prove that FL, okay, I want to prove that FL is congruent to HN, those two segments. So let's start with all of our givens, and notice if I can show, what I'm going to do is I can show that these two blue triangles are congruent to each other, and these two green triangles are congruent to each other. All right. And then once I can show that, then using the segment addition postulate, this segment's congruent to this segment, this one to this one. So I add those up, the sum of HK and NK has to equal the sum of FJ and JL. And so those are the segments that that makes FL and HN. So with a proof, we have to be very detailed. So we're starting with what's given, okay? And then I'm stating that these angles here are congruent, and these angles here are congruent by the vertical angle theorem. Okay, let's make my highlighter a little bit bigger there. All right, and now I can say by side angle side, that the blue triangles and the green triangles are congruent. This means that corresponding parts of the congruent triangles are congruent, so I can say that FJ is congruent to HK and JL is congruent to KN. That's step 4 here. Now, I'm going to be using my segment addition postulate, which has to do with segment length. So I've got to get technical, and I've got to convert from congruency to equality. So that I'm going to now say that FJ is equal to HK by the definition of congruent segments. And now I'm going to add FJ and JL and HK and KN together to give me segment FL and HN. Okay, so the addition property of the segment addition property says that okay, I'm adding these. That's the addition property of equality. I can add FJ and JL and HK and KN. So let me back up here a little bit. So I'm on step 6, and I'm saying that FJ plus JL is equal to HK plus KN and that's the addition property. I'm adding the same amount to each side. JL, or let's look at it this way: FJ and HK are equal, so I'm adding FJ and HK to JL equal to KN. So I'm adding the same amount. So that that's a true statement. And then FJ plus JL is the same as FL, and HK plus KN is the same as HN by the segment addition postulate. Okay, there's different ways that you could have written steps 6 and 7. I could have said by the segment addition postulate that FJ plus JL is equal to FL, and then HK plus HN, or KN is equal to HN, and then use some substitution. To say that FL is equal to HN. So now, but anyways, we're at the point where we're saying that FL is equal to HN, and that's where we want to get. Now the technicality is just to say that, you know, if the segment lengths are equal, then the segments are congruent. So by definition of congruent segments, we could say that segment FL is congruent to segment HN. I hope that made sense.